Welcome back to this new video. We're going to create a parametric facade inspired by the building facade you see on this slide, the North Mediterranean Health Center. We'll also explore an interesting idea for controlling the opening and closing behavior of the panels using a Dynamo script that reads a black and white gradient image. Based on the brightness values of the image, the facade panels will automatically vary between open and closed states, creating a dynamic parametric pattern across the facade surface. We'll start by opening a new generic model family in Revit. After entering the family, we'll change the units to meters. Next, we'll create a set of reference planes that will help us define the main module of the facade panel. The unit itself will be rectangular, so we'll create two reference planes and give them approximate dimensions of around 1 meter by 1.5 meters. These are not the exact dimensions of the original project, but they work well for recreating the concept. After that, we'll move to the front view and create a reference line. This reference line will be connected to an angle parameter, which will control the opening and closing movement of the facade panel. Once the reference line is created, we need to make sure it is properly locked to the reference planes. We do this by using the Align tool and locking both ends of the reference line to the corresponding reference planes. One side is aligned to the first reference plane, and the other side to the second one. Next, we add the angular dimension and associate it with a new parameter called angle. This parameter will fully control the kinetic movement of the facade unit. Finally, we'll create the actual panel geometry using a normal extrusion. But before drawing the extrusion, we'll use pick a plane so the extrusion becomes hosted on the rotating reference plane itself. After that, we'll move to the plan view and complete the extrusion from the beginning of the reference plane all the way to the end. Once that's done, we can quickly test whether the panel is correctly responding to the angle parameter and check if the opening and closing movement is working properly. Next, we'll open a new family, this time a generic model pattern-based family. We'll load the panel family we just created into this new family. Then we'll change the grid dimensions of the pattern to approximately 1 meter by 1.5 meters so it matches the dimensions of the panel. After loading the panel into the pattern-based family, we'll place it correctly on the grid and test if everything is working as expected. Once that's done, we'll load this family into another family environment, specifically a mass family. Now you might ask, why are we using a mass family instead of placing it directly inside a project? The reason is because later we'll use a Dynamo script that needs to read and control the panels directly. For this specific workflow, the panels need to exist inside a mass environment, not a normal project environment, so Dynamo can properly interact with them. So we'll create a new mass family, go inside it, and again change the units to meters. Then we'll create the main facade surface. For example, we can make it around 30 meters wide and 15 meters high. Next, we select the face and use divide surface. After that, we adjust the U and V spacing values to match the dimensions of the panel system. Then we load the pattern-based family onto the divided surface and place it correctly. At this stage, we'll notice an issue: the angle parameter is not appearing. This happens because we forgot to associate the angle parameter properly in the previous family. So we go back into the family editor, select the angle parameter, associate it correctly again, and make sure it's set as an instance parameter. Then we reload the family back into the mass environment. Now the panels are fully controllable, and each panel can respond individually to different angle values. And this is exactly what we'll use with the Dynamo script we mentioned at the beginning of the video. To create this effect, we'll open Dynamo from the Manage tab. The script itself is very simple in concept. It asks you to select a black and white gradient image. Based on the brightness values of the image, the script automatically controls the opening and closing angles of the facade panels. So first, we select any black and white image. Then, if we want to preview it inside Dynamo, we can use a Watch Image node to display the image we imported. As you can see, this image contains white regions and black regions that will directly affect the panel behavior. Next, we define the number of panels vertically and horizontally. These values must match the X and Y inputs of the image pixel node. For example, if we have 10 panels vertically and 15 horizontally, we enter those values so the image can be properly mapped across the facade. Then we define the opening angle range. For example, we can set it from 0 to 90 degrees, or maybe from 1 degree to 89 degrees like in this example. You can customize the opening range however you want. We also need to set the category node to curtain panels so Dynamo can correctly detect all the panels inside the project. As you can see here, we currently have around 150 panels in the facade. Then we use a small Python node whose job is simply to reorganize the panel data correctly before applying the parameter values. Finally, we use the setParameterValue node to send the calculated angle values to the panels. Now when we run the script, you can see the final result. The facade starts showing different opening and closing behaviors directly influenced by the gradient image we selected earlier. If we switch to another image and run the script again, we immediately get a completely different facade behavior and pattern. And naturally, the larger the facade becomes, or the smaller the panel size becomes, the more detailed and smooth the gradient effect appears. For example, here I'm increasing the facade dimensions and doubling the panel count from 15 to 30 horizontally and from 10 to 20 vertically. When we run the script again, the result becomes much more detailed because we now have more panels and more pixels reacting to the image. Thank you for watching. If you'd like to support the channel and also use the script in your own projects, you can download it from my Gumroad page. I uploaded it for a very small price mainly to support the channel and continue creating more content like this. Link will be in the description. And if you enjoyed the video, don't forget to subscribe and turn on notifications, and I'll see you in the next video.